Hi, this is Chris from tutorwithchris.com. Welcome back to my YouTube channel. I'm a professional private tutor servicing Orange County, California. I offer in-person and online tutoring. Please visit tutorwithchris.com to see a list of all of my services. Today we're going to be talking about calculating variance by hand. Unfortunately, it's something that every introductory stats student has to learn. I'm going to show you some tips and tricks today, though, that's going to make that painless for you. So I'm going to show you two formulas. The first one is the definitional formula, and this one is excellent for learning the concepts behind standard deviation. You can follow logically what's happening here each step of the way. The second formula I'm going to show you is called the computational formula, which you see here in black. This one you cannot follow along with logically. However, it's going to give you the same result as the definitional formula, and it's a lot quicker to use, much more efficient. Now, the first time stats students see the formula for variance and standard deviation, well, let's be frank about it, we kind of poop our pants a little. This is what it looks like. It's terrifying. We start to see Greek symbols such as sigma, and then we start seeing, well, hopefully you're familiar with X bar with me. Okay, now when we do this, I've seen lots and lots and lots of students do this as one long addition piece, and there's just 1,000 places to go wrong, to make easy errors. What I would like you to do is to organize your work into a table. So to get started, we're going to be looking at our formula, which is our roadmap. And the first thing we're going to see is we need to know a couple values, one of which is n, which is simply the number of data points we have here. So n is 5. The next thing we need to know is x bar, which is our sample mean. And we use our x bar formula to calculate that, where we take the total of our x's and we divide by the number of scores, which we said was 5, and that gives us 15 over 5, which of course is 3. And then we move on to our next step, which is beginning to fill in this column of the table. Okay, so now that we've calculated those values we needed, we can actually get started filling in our table. And so this second column that we've created, we've just broken down a very simple operation from this larger, more complex equation. Here we're taking each individual x score, which was in this case 4. We're subtracting the mean from it, which we calculated was 3, and we're coming up with a solution of that part of the subtraction. Now in our third column, what we're doing is taking the value that we calculated in the second column, and we're simply squaring it. So 1 becomes 1 squared, which becomes 1. 2 becomes 2 squared, which equals 4. Negative 1 squared gives us 1. And the process of doing this eliminates all of our negative values. Now, at the end, what we're going to do is add each of these values and get this term, which is the sum of x minus x bar squared. If you go back to our original equation, which is our roadmap, it keeps us on track. That's the numerator we were trying to calculate. So now we have this value, which was 10, and we're going to go ahead and insert that into the larger formula so we can solve. So, now we're in the home stretch. We've completed our table, we've broken this complex equation down into easy to follow steps. We are going to now drop that value of 10 into this equation. That was the numerator that we solved using the table. We're going to use n once again, which was 5, minus 1. So inside the radical we have 10 over 5 minus 1. As we do these simple steps, we're going to have the square root of 2.5, and our final answer comes out to 1.581. So before we go any further using this formula, I want to take a moment to address a problem that every student has, and that is confusing these two terms, the sum of x, which we can square, and then the sum of squared x's. These are two completely different values and they're not interchangeable. To demonstrate this point, we have the sum of x squared does not equal the sum of squared x's. So if we drop our value of 15 for the sum of x into these brackets and square it, we get 225, whereas the value of the sum of squared x's was 55. We can clearly see that 225 does not equal 55. Now we're going to take a crack at using our computational formula, which we'll find is a lot quicker and easier than the definitional formula we just completed. To start out, we're going to put our data in a table just as we started to do before. Here we have our x values, we calculate the sum of x, just as we did before, but now we're only calculating one column, and it's a simple one to do. We're squaring each of these values, and then we're summing that so that we get the sum of x squared, which is 55. So moving right along with the rest of our formula for the computational method, we are going to insert these values we've calculated, the sum of x being 15, the sum of squared x's being 55. We drop those right into the appropriate place in the formula. We see that 55 goes here, that 15 goes here. We do a couple of calculations, and I broke it down really slowly, one operation at a time, so that it's easier to follow along with. 15 squared turns to 225. 225 divided by 5 becomes 45, and we do the simplifications, and we come out with the final answer of 1.581, which was the exact same answer we got using the definitional formula. However, we did it in about half the time and with far fewer steps. Thanks so much for watching till the end. I hope you found this video helpful. If you did, please like and subscribe to my channel. And once again, if you're in need of a private tutor and you live in the Orange County, California area, please visit tutorwithchris.com to arrange an appointment. If you're outside of the Orange County, California area, please visit tutorwithchris.com to arrange an online appointment. Thanks so much for watching, and I'll see you next time.